Hello, this is a video for COMP345, Advanced Program Design with C++. This is for week 2, assignment number 1. So in this video, I'm just going to show the PDF of the assignment number 1, a handout, and explain a little bit of how it's going to work. So here's the assignment handout. So first of all, the deadline for this assignment is October 7th. This is worth 10% of the final mark. This is a team assignment. Remind you that every team member will get the same mark for this assignment. So first of all, there's 5 people in the team. So inevitably you will have to divide the work into hopefully in 5 different pieces of work for each of the people in the team. I have actually designed the assignment so that it's divided in 5 parts. Now, that's not to say that you have to assign one part to each individual. That seems to suggest this, but that's not necessarily the case. You can work as a team and design each of the 5 parts as a team. It does not have to be that a single individual is responsible for a single part entirely. It's up to you to divide the work according to what you think, as you may see fit for your team. But there is 5 parts, and of course there is 5 team members in the team. Reason why I divide the code in 5 parts, well, this is also a course about design, so you have to design, I'm forcing you to design the code always so that it's composed of different parts which are somehow distinct from one another, and then part of the exercise is to make these parts work together, right? And also, one of the effects of having each of the different parts is that you will have to demonstrate each part separately. So when the marker is going to grade your assignment, they will want to see each of the different parts to run separately. As you will see, as I will explain during this description, there is description of what is it that you should demonstrate, and it should be implemented using some kind of driver function, which should be a free function, as I will explain later. There are some restrictions that I've listed here, the 7 restrictions here. So let me just go over them one after the other and make sure that you understand what that means. First of all data members of user-defined classes must be of a pointer type. So as you may know, in C++, there's this notion of pointer, which is not something that you used to see in Java. In Java, you have references, but it's significantly different from pointers. And pointers is both one of the strengths of C++, as well as a difficulty. Okay, so the reality is that you can write a C++ program that does not use pointers. And I absolutely don't want you to do this because you would be missing a significant part of what is it to learn C++. So that's why my restriction here is if you define one of your own classes and then you define data members inside of this class, and that these data members are of one of your types, then this data member must be a pointer to an element of this type. It has to be a pointer. In real life, you would have to make the decision as to whether or not it should be a pointer. Here, I'm actually forcing you so that all your data members in your classes, if they are of the type of one of your own classes, they must be a pointer. There is also, as we saw in class, there is in C++ this additional issue that you have to decide when you write some code or classes in which file they should belong. So in Java, you have this one-to-one relationship between a class and a file. The file has the same name as the class, very easy, no such thing in C++. You create your own files and you can put your CPP files and .h files, header files, and then you can put whatever you want in these files. In the project, I'm telling you, imposing you, what are these files, the .cpp and .h files, and I'm giving you some restrictions as to what should be in these files, what classes should be in these files. Okay. I'm doing this to basically make sure that when the markers grade your assignments, that that they can compare and give fair grading by comparison to different teams, by being able to see more easily where things and how things are implemented in each of these files. And then speaking about these files, each of the different parts, as I will explain later, they should be implemented in each their own .cpp and .h file duo, and I'm giving you what's the name of these file duo should be. So you are restricted by that. Another restriction is that all functions implementation must be provided in the CPP file. You cannot use inline functions. So, or technically that actually means that you cannot include the bodies of your function definitions inside of the class declaration, as I explained in the first lecture this week. All class must be implemented must implement a correct copy constructor, assignment operator, and stream insertion operator. So this is one of the basic things which are very important to understand. So in real life, you don't necessarily always have to implement them, but in the project, as soon as you declare a class, it must have a copy constructor, assignment operator, and stream insertion operator. Whether or not you think maybe it does not need it, you must implement it anyway. 5, memory leaks must be avoided. We will cover that in week number 3. 6, the code must be documented using comments. So for every class that you have, there must be a comment before this class that describes what is this class doing. For every method in a class, there must be a simple comment describing what this method is doing. For every function and for every operator, there should also be a comment that precedes this. For those of you who have used Javadoc before in C++, you can actually use what is called Doxygen to do your documentation. And of course, you can use that if that's what you want. Number 7, as I discussed in class already, you are allowed to use any library, either the standard template library or any other library. If you use libraries other than STL, though, you will be on your own too. You should not expect that the lab instructor would know these libraries. And then when you do the presentations, you are responsible to properly, of course, install these libraries to do the demonstration. Okay, so let's go over each of the different parts. So these design restrictions here apply to all the parts. So first part is the map. So here, what you have to do is to implement a set of classes that implement the map. So of course, a map is composed of territories. So that means you need to have a territory class. And then, as I explained in class a little bit, so essentially a map is a set of territories And in order to, and the territories are the nodes of the graph. And then for each of the territory objects, you will have inside of this object, territory object, you have a list or container that contains the list of territories that are adjacent to this territory, thus forming a graph that you can then traverse. So pretty simple, but not necessarily trivial, but actually pretty simple. Okay, so all of this has been well described in the in class during the when I presented the overall project. So all the implementation that you do, of course, must be implementing the Warzone game as described in the general project description. The game, when you start the game, it should allow the user to ask on what map they want to play. Now, there is existing games that have been created, Risk-like games that have been created, that are available on the internet that provide you with some files that describe a map of a Risk-like game. So if you go to this link here, then you will find a list of maps of a game named Conquest. Then you will find dozens of different maps. So there's zip files for each of these maps. And then if you open the zip file and you go inside of the zip file, you will see a .map file. And that's this file that you should be able to open. So this map looks something like this. So you have different sections in this file, for example, describing the continents and then the territories, the names of each of the territory, and then the list of territories that are adjacent to this territory. So it's pretty simple, but I invite you to look very carefully at what is this these files, the format of these files. So essentially, you will have to read these text files and then create the territories as well as the connections between the territories to create your map object. So that's essentially what is part number one. Read a file of this format and create a map object. I'm not going to go and describe all the things here. Of course, we're going to discuss this in class. So for each of the parts, including this, the map part, I'm specifying here what are the files, the file names, all the files, and specifically what are the names of your files that you must have, that must contain your classes and methods, so on, your C++ code. So in this case, you must have two files, map.cpp and map.h, and this is where for example, your territory class and so on will, and your map class, if you have one, that is included in these two files, as I'm describing in class. Okay. So for example, in the CPP file, you have only the implementation of all the methods of all your classes. And then in the .h file, you have the class declarations for the classes that are included in this file duo. As I explained in class, if you want to have more details, please go to the videos for week 1, the first video, and then the video for slide set 1.5 that is in week 4. So you must have this file duo here, plus you must have another CPP file called mapdriver.cpp. In this file, the only thing you will find, or you should have, is a free function called test load maps. So what this free function is essentially a driver for this part. So what it will have, and then everything that this driver must do is actually listed here. Okay. So you should be able, so this, I'm going to read this one, but I'm not going to go into all the details of all of the drivers for each of the different parts. But just as an example here, the test load maps, what it should do is to successfully create a map by reading a set of conquest map files and successfully create a map object for valid map files and reject various different invalid map files, because there could be some files that would be invalid files. Your implementation should be able to gracefully recover from be reading a file that is invalid. Should basically, an invalid file should not make the program crash. It just result in saying this map file was invalid. After a map object has been successfully created, the driver should demonstrate that the map class implements the following verifications. First, the map is a connected graph. Second, continents are connected subgraphs. And third, each country belongs to one and only one continent. Okay. So you see here that I'm specifying exactly what is the code that should be in your implementation, what this code should do, and in what files this code should reside. Okay, so it's pretty clear what you have to do and where it should be in each of the different files I'm imposing you to have. Okay, so here in this table here, I'm giving you more details as to what I've been describing here. For example, here I refer to the map class. So that means here, because I named this this class here specifically, that actually means you must have a class named map. Fast forward here, implemented as a territory class. So here, basically, I'm imposing you to have a class named territory. So it's not a class named country. It's not a class named anything else. It's a class named territory that implements essentially the nodes of your graph or the countries in your map. It should be the class name should be territory. And I'm also imposing you that, for example, sometimes that there are some specific methods in some of these classes, and to specify, and I also specify what they should do. So, for example, the map class should have a method called validate that makes the following checks, as you saw that I specified here, right? Okay. And then finally, you should have a driver called test load maps that does what I described before. Okay, so you see that it's pretty clear what exactly you need to have. I'm not saying either that all the details of what you have to do are mentioned here. Of course, there are some things that I'm not mentioning, as I explained extensively in the class. You have to expect that I'm not saying everything in the assignments. One of your first jobs as a student in doing this project is to figure out the details that are missing. There are things that I don't say. It's up to you to come in class and ask some questions about things that I don't say. Don't go and invent your own interpretation of what it should be if there is something that I don't say. Okay, so that's it for part one. Second part is the player. So the player is essentially the player holds a certain number of territories on the map, and that's the player that will eventually create orders in order to eventually conquer territories on the map and eventually win the game by conquering all the territories on the map. Okay, so you should have a class named player, which should own a collection of territories. You see here that here the player will own territories. So that means actually when you do part 2, the player actually needs to have a class territory. Okay, so there is, intersections between the parts inevitably. Okay, now in assignment number 1, when you submit your code, if you submit each of the different parts separately, it's possible that you have different classes, that the territory class that the player part uses is not the same class as the map class uses. That's allowed for assignment number 1, but eventually for assignment number 2, these will of course need to be the same class. So you have this possibility for assignment 1, but I strongly suggest that you really make, if you're doing the player class, let's say you are as a student are assigned by your team to do the player, that you implement the player class and that you use the territory class that was designed by the person that did part 1, the map. Okay. So you see that it may seem that there are 5 parts and you may think you're going to design each of the 5 different parts in isolation from your other teammates. Not really. Okay. If you do that, your assignment number 2 is going to be much harder because you will have to integrate all these things together. I strongly suggest that you work hand in hand with your teammates already in assignment number 1. So player owns a collection of territories. A player owns a hand of war zone cards, which is defined what that is in part number 5. The player class contains a method to defend and to attack, because the player will decide, make decisions as to, for example, what territory it wants to conquer and what territory of their own they want to protect. So, for example, by creating when, for example, you do your deploy orders, you do them in places either where you want to do an advance, or in a place in the map where you want to protect a certain territory by adding more armies. So you will make these decisions eventually by calling to defend and to attack. So to defend, the idea of the to defend method is the list of territories that you want most to actually defend, that you want to concentrate possibly armies in this place. And the to attack method, the concept is that it returns the list of territories that you most want to conquer, enemy territories. So right in assignment number 1, I want you to write down these methods, not necessarily at this point that they will make judicious decisions, but the to defend and to attack method should simply be a method that returns a list of territories. And in assignment number 1, that would be arbitrary territories. And then a method that the player should contain a method that is called issue order. Eventually, there's going to be a game engine, and the game engine is going to go in a round robin over all the players in the issue order issuing phase, and we'll call issue order to each of the players. And then the effect of this method is eventually going to be, when you call issue order, the player is going to decide what kind of order to create, and then it's going to put it in its own order list, which is subject of another part. The order list itself is a subject of another part. Then eventually you must also have a free function named test players that should be in the file player driver.cpp. And this free function should essentially exercise the code to actually demonstrate that all of this here is actually present in your code. So you see right away that there is, a difference in terms of difficulty or amount of code that there is to write for each of the different parts. In assignment number one, definitely the part number one is the most difficult. Not that it's super difficult, but it's the most amount of code to write because it forces you to have to write from a file, read from a file, somehow parse what's in the file, and then create territories, connect the territories together and create a map. That's kind of much more significant than what the player part is. Okay, so you have to, inspect this when you want to assign the different duties. You possibly, I would suggest that you have more than one person working on part number one. If you have somebody who's willing to achieve that alone, fine. But part number one is significantly more work than the other parts of this assignment. Part number three, orders list. So the orders list, as I just said, the concept is that each player should contain a list of orders. And this is the orders that they have created during this turn, which will eventually be executed by the game engine. Here I'm projecting on the things that you will have to do eventually. Assignment number one does not have to do the execution of the lists. And by the way, also the orders that you put in the list here in assignment number one, that will not be real orders. We'll be creating a blank order object and then putting it in the list. Essentially, part number three is just an exercise in how to create a list, which I would suggest should be an STL container into which you put objects of type order. Okay. So here's describing what this order list should have. So you should have the order list should be a class by itself. And then this class should have a move method that allows you to move an order to a different place in the list. Okay, or another method named remove that allows you to actually remove an order from the list. As I described in the game, the different kinds of orders, because this is here a list of orders objects. So you must be able to, you should have an orders class, and then the different kinds of orders should be implemented in your implementation. These are the deploy, advance, bomb, blockade, airlift, and negotiate orders. So you should have an order class that allows you to create orders of these different kinds so that you can put them in the list. All the orders must have a validate method that verifies if the order is valid. All you have to have now is a method validate. It does not have to validate, implement the code to validate the orders. We're not there yet. So you must have, at this point, an order class that has a method validate that you can call, but it just does, for this moment, it does nothing. All the orders must have an execute method that will result in some of game actions being implemented eventually. At this point, all I'm asking is that all the orders have an execute method that you can call. Later on, you will, in part number two, you will implement what these different orders do when you call their execute method. You see here, I'm basically asking you to build some kind of scaffolding of your code to become, right? Many of the things that will need to be there are not there yet. For example, the validate and execute, all that you have is a placeholder method that is there, but actually it does nothing if you call that. This is just an exercise in learning how to create your CPP files, your .h files, and then work together as a team to create all of these files and all of these classes that somehow you can compile together. That's what is assignment number one. it may seem like this is not much of a goal for an assignment, but you will clearly see that it's not that trivial because of the way that C++ is designed, so that you should know what should be in your CPP files, your .h files, how to hash include each of these files together so that it actually compiles. Okay, so, and here is a more detailed description of what this order lists part should do. Part number 4 is the cards deck and hand. So in this game, there are cards. So what I want you to do here is to implement, for the part number 4, is to implement the cards, each of the different cards, and then to implement a deck of cards, because when the player conquers a territory, they will have to draw a card. So then you must have a deck of cards from which the player will draw a card and then put it in their hand of cards. Essentially, the deck of cards is a list of cards that you draw from, in which case the card is put into your hand, which is another list of cards that you can play. There's only one deck of cards from which all the players can draw from, and each of the players have their own hand of cards. So again, this one is pretty straightforward. So you must have a deck class that must have a draw method that allows the player to draw a card from this from the deck and then place it into their hand. The objects of type card must have a play method that is called to play the card. When you play the card, eventually it's going to create an order that the player is then going to put into their list of order. But that's not what this part number 4 is to do yet. I'm just telling you what is going to happen. At this point, all you care for is that your card class must have a play method that will be used eventually in assignment number 2 to create an order that's going to be put in your list of orders as a player. Okay, and then you must have a, well, all of this here must be implemented in the file duo named cards.cpp cards.h. Then you must have another CPP file called cards driver that should contain a single free function called test cards that somehow demonstrates that you can have different players that can that have their own hand and that can draw from the deck and then put cards in their own hand. And then when they play, when they call the play method of their own cards in their own hand, that it calls the play method, and one thing that it should result in is that the card is put back into the deck. Okay. So again, not super difficult, but this is only the first step. Part number 5 is some kind of embryo of what's going to become the game engine. Game engine is essentially some kind of loop or controller that is going to control how the game is evolving in terms of states. So if you remember in the project description, I have described what are all the different states of the game, what they consist in, what will happen in each of these states. So here, basically, I'm asking the person doing this part number 5 here to implement some kind of DFA implementation that is essentially allowing the user very simple program here. Don't think that because this is called game engine that this is very complex. It's again, it's really an embryo of the game engine, or it's a small part of what the game engine will become. So here, all you have to do is to create some kind of console interface that allows the user, that tells the user what is the current state of the game, then the user is allowed to type a string that represents a command. And if the user enters the right commands that lead to a transition to another state, then the user is told, well, you are now in this other state, which allows the user to enter another command to go to another state, and so on and so forth. So essentially, you're implementing some simple DFA here. So what are the states that should be modelized in this DFA? First, when you start, it goes to the start state. Then if the user enters the command load map on the console, then this will make the DFA to switch to the map loaded state. Then in this case, if you are in this state, you can enter the load map command again and again and again, and you still stay here in the map loaded. And if you enter a validate map command, then it goes to map validated. If you are in map validated, you enter add player, it goes to players added state, in which case you can type the command add player again and again and again. If you're in players added and you go assign countries, then this goes in the main play. So you see that this is the startup phase, right? Which I described somehow in slightly different terms, but which I describe in the project description document. So once you go assign countries here, you go to reinforcement phase. Then when you're in reinforcement phase, you can issue an order. Once you issue an order, then you can issue many orders, or to signify that you want to end issue orders, in which case it executes the orders. In which case you can say execute order, and so on until you type the command to end execute order, in which case you return to reinforcement, or you type the command win, which makes you go to the win state. And when you're in the win state, you can type the command either end to end the program or play to go back to start. Okay. So you see that this is, don't think that this is actually the real thing, game engine. This is just a simple assignment to have a small portion of what the game engine will eventually become. Okay. So that's it for the 5 parts. Again, here I'm specifying also in what files all this code must be. So that's GameEngine.cpp, GameEngine.h. You must have a file GameEngineDriver.cpp, which contains a free function called test game states. Eventually, that's what I didn't mention in the beginning, but eventually what you're going to have, and that's what is described in the next paragraph, I believe. Yes. So here, okay, let's start with the start of the paragraph. You're expected to submit a group of C++ file implementing a solution to all the problems stated in part 1, 2, 3, 4, 5. So you should have each of these parts implemented in each of the files that I have mentioned in each of the respective parts. Then you must also have one file that will contain the main function. And this main function, what it will do for now, when you execute the program, it will call each of the test methods that I specified in each of the parts. That is whose goal is to actually exercise the code and to demonstrate that it does what the assignment description says that it should do, right? Which I describe pretty clearly in each of the different parts. So your main function will call each of the 5 test methods that I've described before in each of the different 5 parts. So that's what essentially, that's what you have to deliver. Now, one of the difficult aspects always when you work in teams, especially if you don't necessarily know the people very well that you're working with, is to get together. Well, first of all, form the teams, get together. I would highly suggest that you get together and have a reading together of this assignment and the project, and you discuss things as to what is each of you, your current understanding, and see if you all agree on what is to be done and what kind of approach you'll use to solve some of these problems and so on. It's very important to have some discussions, live discussions with people before you start coding. If you just say, oh, you have part one, you have part two, you have part three, you have part, and you assign all the parts, and you say, okay, let's do the code for our own parts. And then the day before the assignment is due, we'll just put the code together, and then that's what we'll submit. I can tell you that it's not going to work. Okay. Some teams, unfortunately, better or for worse, that's what they attempt to do for assignment number one. It is not going to work. Okay. You need to discuss with the other teammates to agree on how you're going to design the intersections between each of these different parts. If there's no discussion, it's not going to work magically. Okay, very important before you start coding, or throughout the project for that matter, that you have good communication with your people in the team. So you will submit this code by uploading a zip file in the Moodle assignment submission that's already on the Moodle page. Please do not submit all your IDE folders in this zip file. It's going to create humongous zip files, creates a lot of problems. If the markers want to download your code, it's going to be creating a lot of problems. So the only thing that must be in this zip file is your .cpp and .h files. That's it. Okay. So that's about it for this video. So I see you in class.